Hey guys, this lesson we're going to look at personal loans and simple interest. Some real life stuff related to some loans. Not every example we'll look at is totally on point, but that's alright. So, simple interest formula is principal times rate times time. Interest equals principal times rate times time. Principal's the starting amount. Rate is like your interest rate, your percentage. And time is how many days, months, or years. Typically, we're looking at years, but I guess it depends on what your loan is for. Some places like those payday loans and things like that, those are shorter, so that would be measured in days, probably. So Chad needs to borrow $2,200 to have corrective eye surgery. He obtains an 18-month loan with an annual simple interest rate of 7.5% from his credit union. Calculate the simple interest paid on the loan. Interest equals principal times rate times time. So when you're looking at this, you need to look at the measurement used, really, the time measurement used really for the interest rate. So when it talks about it, it says an annual simple interest rate. So that means per year. So our rate is 7.5%, which would be 0.075. Our time is 18 months, but we need those to match the months, and then this is measured in years. So let's change that 18 months. That would be 1 year, 6 months, or 1.5 years. That's going to be a better measurement to put in there, is the 1.5 years, because we do need those to match up. And then the principal is $2,200. We're going to find the interest on that. Now, when we solve this, that is only the interest that will be paid on the loan, not like your total. So we're going to multiply this out. So let's get out our handy dandy calculator. All right, I fixed up my window on that a little bit. So on our calculator, we need to do 2,200 times 0.075, and then times the 1.5 years. So the interest on that will be $247.15 or 50 cents. So that's just the interest, though. So at the end of the 18 months, that means that he will have to pay them the original principal plus the $247.50, which is not terribly difficult to add, so it's going to have the 50 cents, $2,447.50 will have to be paid total. Now, this situation is not actually talking about where you're making payments each time. It would be kind of an estimate that you would then divide that by 18, and that could be what you're paying. But it's actually a little bit more of a complicated equation that's typically done in real life on that sort of thing. This would be this sort of example would say, on that day you show up with $2,447.50, or they come after you or whatever. Not like a loan shark, like to break your thumbs or whatever, but like creditors calling and things like that. But that's not totally real life. It's just for the math problem right there. So same sort of thing. Here's another simple interest. Simple interest is commonly done among, I guess, friends. I mean, if you're really a friend, maybe you wouldn't charge interest, but sometimes. So Philip agrees to lend $850 to his friend Joe to help him travel. 9 months later, Joe paid $850 plus $51 interest. What annual interest rate did Joe pay to Philip? So that is the interest. So we're going to put that in for the I in I equals PRT. The principal we know was $850. We don't know the rate. That's what we're solving for. And we do know that it was 9 months later. So since that's months, and here we're talking about annual rate, we actually need that to match up again, like we said. So 9 months out of 12, that'd be, well, the easiest way to write it would just be a fraction, 9/12 of a year. Or make it be a simple fraction or a percentage or a decimal, anything sort of like that. All right, so we're solving this out, trying to solve for r. So to get rid of this fraction, you're going to multiply by the reciprocal to the other side. And then to get rid of the 850, we're going to divide by the 850. So our rate we can get from this equation, this math we have set up over here, 12/9 times 51, and then divided by 850. So this gives us our answer in scientific notation. You can manually change that back by moving the decimal to the left 5 spots, because that's what it says, left 5 spots. So moving it left 5 spots, since it's 9 point something, you move it 1, 2, 3, 4, 5. Fill in all those zeros. And I just realized I messed up there. I did it twice. Should have stopped. I hit enter twice and didn't even notice it. 0.08 is right there. .08, which is 8%. That makes more sense. That was just because I somehow accidentally did it twice. I don't know how. All right, same formula, so we're using that I equals P RT. Borrows $240, and after 30 days he gets his trumpet back by paying the pawnbroker $288. So the principal is $240. What is the annual rate of interest? So we're solving for T. And again, this is annual. This is 30 days. So since that's 30 days, that's 30 out of a whole year would be 365 days. And that just equals interest. So we have to look at what our interest was from 240 to 288. That means that it gained, you're just subtracting here, $48 is our interest there. So same sort of solving that we did before. We're going to multiply by the reciprocal times the 48 and then divide by 240. Make sure we only do it once this time so I don't get a weird answer again. So that's 365 over 30 times 48 and then divide by 240. So here we have kind of a weird answer. We'll put it back in context. Changing that to a percentage. I'm going to move it 2 places. That's 243. .3 repeating. 10%. So that's a lot of interest, and that's because it's gaining only, in only 30 days, it's going up by $50, which is a lot. So a lot of times those really short-term loans like that is actually true, like over 100% interest when you look at the annual rate of interest. All right, so some more vocab here. Discount note is just a type of loan where interest is paid at the time the borrower receives the loan. And then a bank discount, the interest charged in advance in a discount note. So Sally took out a $500 loan using a 10% discount note for a period of 3 months. Determine the interest she must pay to the bank on the date she receives the loan. So just putting that back in context real quick. You pay the interest up front. So it's like you're going to borrow $200. They're going to figure out what the loan would be, how much interest that would be. You pay that up front so that the bank gets their money up front, basically, and then you pay back the rest of the money later. So a 10% discount note for a period of 3 months. Determine the interest she must pay back to the loan, back to the bank on the date she receives the loan. So we're taking our simple interest formula, I equals PRT. The I, the interest, is the amount that we're solving for right here. We know the rate is 10%. The time is 3 months, so we'll do 3/12 of a year. And then the principal was $500. So just the I in the simple interest formula is what they're talking about for owing this money up front. So 500 times 0.1 times 3/12. $12.5. So 12.5, remember that's money, so that'd be $12.50. That's not that much, but you're only borrowing $500. So the net amount of money she receives from the bank. So instead of getting the $500, she's getting the 500, basically minus the $12.50. It's $487.50. So we're going to look at the actual interest rate. This is something that sometimes you'll see in loans, looking at the actual interest rate. So when we take our interest equals principal times rate times time, our interest was $12.50. The principal, we're only going to take into the account this $487.50. To find the actual rate, and times time, we had that was 3/12. It was 3 months. So same thing we've done to solve these out before. Multiply by 12 over 3. Twelve divided by 3 is only 4, so that's really what we're multiplying there. And then divide by the 487.5. So 12 over 3, that's 4, times 12.5, divided by 487.5. So it's really 10.25%. Actually, I think that was 256, so 26. That's just a kind of a weird calculation based off of how they subtract the money from the amount that you're borrowing and going for it that way. There's a lot of tricks like that the banks use that make it seem like you're getting a better interest rate. They told you you're getting 10%, but it's actually 10.26% or something like that. Small things that they don't seem to make a big difference. You look at it and you're like, oh, that's not that big of a deal. But then when they something like that's done to millions of customers, then that's a lot of money. So it adds up. All right, so here we've got a situation. We're going to look at two options. Wants to buy a $2,000 bike. You can put half down and then pay $1,150 in 6 months, or you can pay $500 as a down payment and pay $1,700 in 6 months. Which payment option has the higher annual simple interest rate? So we're looking at two different things. I'm going to split my page in half here. So we got option 1 and option 2. When we're looking at interest, now obviously if you factor in whether or not he has that extra money for the down payment, that's a separate factor in deciding what we would take here. But we're just looking at just the interest rate. That's what we're looking at here. So on option 1, he's paying $1,150 for the other $1,000. Since it's $2,000, he's paying half of that up front, which means our interest is $150. The principal is $1,000. And we're trying to find the rate, but the time is 6 months, which would be half of a year, or 6/12 if you want to do it that way. And then we'll solve that out for R, but let's set up the other one while we're at it. Interest equals principal times rate times time. In the second situation, he can pay $500, which means he's going to borrow $1,500, $1,500. Again, we don't know R, but we do know time is 6 months, so half of a year. And this time the interest, if he's borrowing $1,500, he has to pay back $1,700. That's $200 interest. So we're going to solve both of these out. 1,000 times 1/2 is 500. That's pretty easy. And then same thing here, 1/2 times 1,500 is 750. And we're going to now use our calculator. 150 divided by 500. It's okay to drop the same amount of zeros from each of those, so I'll drop 1 0 just to make less typing. So that is a 30%, 30% interest rate. On our other one over here, we have 200 divided by 750. Could have done the same trick and dropped to 0, but I didn't. 26.6 repeating, so 6.7, we'll round it to % interest. So this is kind of a really weird situation where you actually are paying less of a percentage by borrowing more money, which doesn't usually happen that way, but in this particular situation with the bike shop. Now, bike shops aren't typically banks, so they probably don't follow all those same rules. All right, so Some more vocab. We have partial payments if you pay less than the full amount. Typically, that's what you would see for a car loan or a home loan, a mortgage, things like that. Most times that's what it is you don't pay the whole thing, you just pay monthly payment sort of thing. And the rule is that if you pay a partial payment, it first goes towards the interest, and then whatever you pay in addition to interest goes towards the principal. But so if you're paying $50 a month or something like that, that $50 would first pay off whatever the interest was that added up, and then pays toward the rest. Now, here's another rule, banker's rule. It says that to calculate simple interest when applying the United States rule, it considers a year to be 360 days, and any fractional part of a year is the exact number of days on the loan. So we've just got a little chart here to help us kind of figure this all out. January has 31 days, so if you look down the chart, you can see that it goes, that first column goes all the way down to 31. Then February only has 28, unless it's a leap year. So you can see that that then has 28 days in the month, which means cumulatively it's 59 days so far of the year. So we have this chart, we can use this to help us figure out how much time between two dates and things like that. All right, so using that table, we're going to determine the due date of a loan that you made on March 15th, and the loan is for 120 days. So we're going to look at March 15th on the chart. January, February, March 15th is day 74. So if it goes out 120 days from there, 120 plus 74 is 194. So we're going to find day 194. So that's going to be the 13th of July. So that's day 74. We'll write it out here. Plus 120 is 194, which is July 13th. That's what we said. Sort of the same idea here from April 18th to July 31st. April 18th, so January, February, March, April. April 18th, that is, come on, day 108. And we're going to July 31st. Be day 212. So from 108 to 212. So number of days in between there. 212 minus 108. It's 104 days. So you could do the same, find the number of days of, from Phineas and Ferb. You can go summer vacation, numbers reminded me of it. You can figure out when the last day of school to the first day of the next school year. Typically it's not 104 from the song. At least not in Arizona, because we go back to school earlier than some other states. They go back after Labor Day. At the end of August, we go back early August. All right, so here we're looking at borrowing money to pay for a flight, 120-day loan for $400 at an interest rate of 12.5%. Kathy uses some of her birthday money to make a partial payment of $150, and she makes a second partial payment of $100 on February 2nd. Determine the due date of the loan. So since this started on November 1st, let's go back to our chart. November 1st is day 305. Oops. And it's a 120-day loan, so add 120 days onto that, you get 425. Now, that's more than a year, so we need to subtract the year from it, 365. And you can use a calculator if you want. So that's 60. So it's 60 days into the next year. So now we need to go back to our chart. 60 days, right there, March 1st. And then that's 2006, so it'll be March 1st, 2007. Which makes sense. Most of these dates coming up here are in 2007, so that's good. Determine the interest and the amount credited to the principal on January 25th. So we're going to figure out how much interest up until January 5th when she makes that first payment. Just remember, your payment first pays off the interest. So here we are, January 5th. We got to get how many days from the beginning, which was November 1st, which remember was day 305. So to finish out the year, that's 60 more days to get to the end of the year. And then to get to January 5th, that's 5 more days. So that's 60 days to finish the year plus 5 days. That's 65 days later. So we're going to figure out how much interest has been charged in 65 days. So we'll use our formula, interest equals principal times rate times time. We know the time is 65 days out of a year, but remember we had on that last note, or that other notes page, the vocab that said we just use 360 days. Look at the banks being nice to us and giving us that free time. The rate is, what did I say, 12.5%. And the principal took out a loan of $400. So we can multiply this straight out, 400 times 0.125 times 65 over 360. So the interest in that amount of time would be $9.03. So how much, the question is how much interest, so that's interest is $9.03. and then the amount credited to the principal. Look at how much she paid. It says you pay the interest first and then the principal. So $150 was paid total. $9.03 went to interest, which means the principal payment was $140.97. We're just doing the 150 minus $9.03. $140.97 to principal. So now from that date of January 5th to February 2nd, it kind of starts over. So if that much was paid off, we're going to take the total original loan of $400 and we'll subtract the $140.97. $259.03. So that's our new principal because we paid down the principal the other amount. That's our principal. Our rate is still 12.5. That did not change. And now we need the time again. So this time we're going from January 5th to February 2nd. So let's go back to our chart. January 5th is day 5. February 2nd is day 33. So from day 5 to day 33, that is 28 days. So we'll put the 28 days, again, at a 360. That's what they said they use for calculating this. So we'll figure out how much interest it was again by multiplying this out. So the 259.03 times 0.125 times 28 out of 360. So the interest that adds up till then, in that short amount of time, 28 days, was $2.52. So her payment first, they pay the interest, $2.52, and then the rest of the $100 goes to principal. So 100 minus the 252. So the rest of that 97.48 goes to principal. So, to determine the amount of money that Kathy must pay on the due date, We can subtract the 97.48. That's 161.55. Now, that doesn't include any more interest that's added up, so you have to recalculate that with the interest. So that is our principal now, 161. The rate is still 12.5. And we got to figure out the time from February 2nd until the due date, which was March 1st. We figured that out in part A. So from February 2nd to March 1st, that's day 33 to day 60. So from day 33 to day 60, it's 27 days. So we'll put that as our 27 days out of 360. So $1.51 will be interest. Plus the principal, which is the $161.55. $161.55 plus $1.51, which means the total payment that needs to be made is $163. And 6 cents. So that's a super complex problem, breaking it up, figuring out how much needs to be paid at different times. Remember, you subtract the interest first, all that sort of stuff, but that's real life. That's what loan calculators kind of work out for you when you figure all that out. So go ahead and complete the worksheet that's in the Files tab and get that submitted. And I'll talk to you next time.